Okay, you guys, I'm not sure when I was going to be here or gone, so I'm going to have and record this lecture here. So you need to be on your 462 notes. Feel free to pause this video anytime you need to, but 462 notes, and we're in the middle of the page after the inverse tangent stuff we dealt with the other day. So if the sine of b is equal to 13 over 20, then the inverse sine of 13 over 20 is equal to the measure of angle b, or the measure of angle b is approximately 40.5416 degrees. If you type this into your calculator, you'll get this answer. Again, if your calculator is not in degrees, you need to fix that. So part 2, you try. Fill in the blanks using the given information, round to the nearest 10,000. So go ahead and pause the video right now. Try these out. Once you're done with it, start playing the video again. Okay, so hopefully at this point you are done with that. You can start playing the video again here. So if the cosine of c is equal to 1/2, then the inverse cosine of 1/2 should be equal to the measure of angle C, or the measure of angle C is equal to, we should have gotten exactly 60 degrees. If tangent of x is equal to 45 over 31, then the inverse tangent of 45 over 31 should be equal to the measure of angle x, or the measure of angle x. Again, if you type this in, the inverse tangent of 45 over 31 should have come out to 55.4375 degrees. That's the nearest 10,000th if you see that there. Here we have this inverse sine of 3 over 4 is equal to the measure of angle y. So here we can write the sine of y, I'm going to put that in parentheses, you don't have to, is equal to 3 over 4. And that the measure of angle y is going to be approximately 48.5904 degrees. Okay, again, to the nearest 10,000th. So then we go on to part 3. That asked you to solve the triangle. So when you were asked to solve the triangle, you were asked to find all missing angle measures and side lengths. I would highlight this part right here because from now on I'm going to ask you to solve the triangle, and that means that you need to understand that you need to find all missing angle measures and side lengths. Okay, so I won't include this part from now on. Round to the nearest hundredth when necessary. Says this one is done for you, so you can see what I did. So I don't have one of the sides, so AB I wanted to solve for. I called that C. And I did 24 squared plus c squared equal to 30 squared. Now, what did I call it lowercase c? Remember here, if our uppercase c is here, this is little c. Across from big A is little a, and across from big B is little b. So those are our different measures there, and I can define it without having to put AB equals here. So solve for that Pythagorean theorem, you get 18. If you want to solve for big C, and I just picked, you could have solved for big B here, but if I want to solve for big C from big C, okay, cosine is adjacent over hypotenuse. And so since I wanted to solve for C, I know my adjacent to be 24 and my hypotenuse to be 30. So I set up the cosine of C equal to 24 over 30. To solve for C, just like we did in the last example, we take C is equal to the cosine inverse. So the measure of angle C is equal to the inverse cosine of 24 over 30, which comes out to approximately 36.87. You can reduce these fractions. You don't have to. It's just an extra step there. And then the last one, we want to not use rounded answers as much as we can. But in this case, you're solving for a third angle in a triangle. You can always just do 180 minus 90 minus whatever you got to find your third angle, or in right triangles, 90 minus the angle that you have to find your third one. So this is one of the cases where you use a rounded answer. So those are our 3 pieces that we were missing. So find all missing angle measures and side lengths, and we did that. So go ahead and pause this video and see if you can do number 5 on your own, and then come back to the video to see what I did and see if it works out for you. So at this point, hopefully you have finished it. If you did this correctly, you should have gotten your little c to come out to about, let's back that up just a little bit, to about 8.06 inches. You should have gotten your measure of angle A to come out to about 60.26 degrees, and your measure of angle B to come out to about 29.74 degrees. If you got all of those, I would fast forward this video and move on to the next step. If you didn't, I'm going to work through those here. So I found little c first, which little c was here. I set up 4 squared plus 7 squared equal to c squared. 16 plus 49 is going to give us 65 equal to c squared. And we can take a square root of both sides to get c to be approximately 8.06 inches. To the nearest hundredth is where I'm rounding everything. So that's my first answer there. I can then move on, and I found the measure of angle A, but you can find whatever you want. And I figured out in order to find the measure of angle A, I knew the opposite and the adjacent. So I'm going to use these three pieces to solve. So opposite and adjacent is TOA, or tangent. It's the tangent of the angle, so I'm going to put my A in there just to use that, is equal to opposite over adjacent. So 7 over 4 is what I'm looking at here. To solve this, we're going to take an inverse tangent of both sides. So the inverse tangent here is going to cancel out, and then the inverse tangent here is what's going to solve it. So you take the inverse tangent of 7 over 4, and you get your measure of angle A to be approximately 60.26 degrees. And then last but not least, I just simply can do 90 minus that 60.26 and get my measure of angle B to be approximately 29.74 degrees. Okay, I'm going to pause there for just a second, see if you need to go back and review anything, feel free to do that. And then we're going to keep moving on here. You're going to see me go back to this because I've never used the screen recorder before, but we're going to use it here. Okay, on the back side, real world problem, so part 4 here. Number 6 says, at what acute angle measure does a 16-foot ladder meet a house if the base of the ladder is 5 foot from the base of the house? So you guys are going to see my lovely drawing skills here, which are not very lovely. We are going to assume a right angle here, so I talked about the fact that we're going to make some assumptions. So there's my house, and then here's my ladder up against the house. So really, really good drawing there, but you get the general idea. So the picture that I'm really looking at is this right triangle right here. And you have a right angle, so we want to draw that in. It says we have a 16-foot ladder, so this side here is 16 feet long. The base of the ladder is 5 foot from the base of the house, so between those 2 points is 5 foot. And we want to figure out what acute angle measure does a 16-foot ladder meet a house. So where does it meet the house at? And so we want to find this angle measure here, so I'm going to call that X. So to set this up, I look at this angle. I'm going to change colors here again. So I look at this angle. I look at the side. This is the opposite side, and this is the hypotenuse. So if I remember SOHCAHTOA, this is something to start writing down for yourself. But SOHCAHTOA is opposite and hypotenuse is going to be sine. So I'm going to set up the sine of the angle. So that's X here is equal to the opposite over the hypotenuse. And then I'm going to solve. So when I want to solve this, I'm going to be solving the inverse sine of 5 over 16. And that's going to come out to about 18.2 degrees. It doesn't say what to round to, so I went ahead and went to 1 decimal. If you went to none, that's fine. Number 7, and again, feel free to pause this and try it out and then come back to it. The Americans with Disability Act, or ADA, has specified that handicapped ramps must meet any horizontal plane at an angle measure of 4.75 degrees or less. If a handicapped ramp has a rise of 4.5 feet and a run of 38 feet, does it meet the ADA specifications? So we kind of have 2 drawings in this picture, because we have one where we know that it has to be this, so 4.75 degrees or less is right there. So it meets, the ramp meets a horizontal plane. So here's my horizontal and my ramp. So that's what that is. That's what I know I want it to be. And what we're saying is we actually have one that has a rise of 4.5 feet. So it goes up 4.5 feet and a run of 38 feet. And the question is this angle within the standard? So we want to find that angle measure and solve. So here I have an opposite and an adjacent. So I'm going to do a tangent of X equal to that opposite 4.5 over adjacent 38. We do have those units being the same. And then we solve with an inverse. So I get X is equal to the inverse tangent of 4.5 over 38. And the inverse tangent of that is going to come out to about 6.75357 degrees. And the question is it within, is it this or less? And the answer is no. So we can answer this question in just one word, but with all of that work showing. The last question on here, number 8, write your own real world problem that requires the user to set up an equation, the inverse cosine of 12 over 21 equal to the measure of angle X. So there's a lot of things that you can do in this one. My example, and you can make your own example here. So essentially I'm going to draw the picture and then I'm going to think about the problem, is if I want to make this X, okay, so that the measure of angle X is there, the inverse cosine, I can flip this to say that the cosine of X is equal to 12 over 21. So the cosine of X is adjacent over hypotenuse. So this is adjacent and this is hypotenuse. So my adjacent is